Sharing my screen. Okay. I hope my screen is visible.
Yes.
Okay. Just a brief recap of what we discussed last week. So recall we already started the second part of this module, and one of the main chapters for the second part is IoT protocols. What I've done last week, we have introduced IoT protocols in general, how it is different. Excuse me, how it is different from traditional network protocols. Okay, so quickly I'll browse you so you recall the reason why we need to have specific protocols for IoT. You will see the main reasons here. Low memory, such network have very low memory, low power, low bandwidth, and high packet loss. So this is the characteristic of an IoT network. So this is why traditional protocols that we use on in our normal network, even Wi-Fi and everything, is not appropriate. So this is why we need to devise new protocols that are lightweight, that fits those requirements for a IoT. Okay, so and we have seen at the different layers of the OSI, for example, at the physical MAC layer, we have IEEE 800.15. This is for IoT. At the network layer, it is 6 low wireless span for IoT. At the transport layer, it is more UDP, which is favored. At the application and session layer, it is in terms of MQTT, CoAP. These are things that we are going to start discussing as from today. And then you have the application layer protocol. So these are main protocols you need to recall and where they situate in the OSI protocol stack in the OSI layers. And then we have browsed through the main protocols again. So the main ones being, we have the messaging protocol like MQTT, CoAP. We are going to start discussing this today. At the lower level layer, at the data link layer, we have 800.15.4. At the network layer, we have 6 low wireless span. We have briefly discussed last time. At the transport layer, we favor more UDP. The reason why we favor more UDP was discussed last time compared to TCP. At the session or application layer, we have already mentioned MQTT, CoAP, and everything. These will be discussed in more detail as from today. So I had briefly introduced MQTT to you. Today we'll discuss it in detail. Yeah, these are a few things we have discussed last week. Introduction to IoT protocols. Today we are going to take one of such IoT protocol. We move on to part 2. I've already posted these notes. So part 2. Here it is. Again, IoT protocols. We are going to start with MQTT. This is one of the most popular IoT protocol that we have. We use in many scenarios. For many IoT case studies, people prefer to use MQTT. We'll see why. How MQTT. So the objective of this lecture here, hopefully we'll finish MQTT today. The whole objective is to know what is MQTT, how MQTT works, how messages are exchanged, what are the different formats for the messages, what are the different fields, especially MQTT is based on the publish-subscribe architecture. What is this publish-subscribe, how it works? So all these details you should be aware, and you will be assessed on those details. However, definitely you will have a question either related to MQTT or CoAP or both. You can have both, because two most important protocol when it comes to IoT messaging. So either it is MQTT or it is CoAP. So today we are going to discuss MQTT. I think next week I have a further discussion on MQTT implementation. I will give you some homework to do. Then we'll discuss in detail MQTT implementation. Then the following week we are going to discuss about CoAP. Okay, let's make a start with respect our MQTT lecture. So basically, MQTT stands for Message Queuing Telemetry Transport. Okay, it falls mainly under the session layer in our OSI layers. It is not a new thing. It was developed in 1999, even before IoT. But then it was standardized in 2013, and where it was prescribed for IoT. For a reason why we have gone for this protocol, because it is lightweight. It's mentioned here, public subscribe messaging protocol designed for lightweight M2M communication, machine to machine communication in constrained environment. So it fit our IoT case study, okay, our IoT scenario. It was already designed well before by IBM, but then it was found to be one of the most appropriate protocol for IoT, because it operates even when there's low bandwidth, low power, low memory. You can still use MQTT. Okay, so we have already said it is a lightweight publish subscribe protocol. So this publish subscribe, you need to understand this very well, okay, because the whole protocol is based on publish subscribe. And what is publish subscribe, how publish subscribe works, this you will be access on it. So this is why you need to understand this very well. As we proceed, you will understand it. So for remote sensors and control devices through low bandwidth, you see here it satisfies this criteria of low bandwidth and reliable or intermittent communication. This is very important here, that MQTT, even if the connection is unreliable, where we are saying the connection between the sensors and the client, even if this connection is unreliable, it is intermittent. Intermittent means you have frequent disconnection in the network. So you know, some protocols assume that you always have a connection. When there is disconnection, it crashes, it cannot forward the information and everything. But however, in MQTT, even for intermittent, unreliable intermittent communication, it can still work. This is the good thing, and this is why it is appropriate for IT. This is why MQTT is so popular, because it works even when you have disconnection. It is able to continue to work and recover from whatever disconnection, and how you're going to see as we proceed in this lecture. Yes, let's proceed. Yeah. Yeah, so one of the main things why it is appropriate, I've already mentioned, it is lightweight, supported by the smallest measuring and monitoring devices. It is suitable for very small sensors, Arduino board and everything. It can transmit data over far-reaching networks. It can transmit data over sometimes intermittent networks. I've just mentioned about what is intermittent network. So when you have frequent disconnection, where you cannot guarantee a continuous a connection. This is called an intermittent network. Yeah, so I've already mentioned it is based on the publish subscribe architecture. Okay, so in a publish subscribe architecture, you have three components. One that is called the publisher, one that is called the subscriber, and one that is called the broker. So you need to understand the role of each one. The publisher, normally, these are the sensors that are reading the values from the environment. For example, you have a temperature sensor reading temperature. You have a proximity sensor using this reading distance, measuring distance. So these are the what we'll call the publishers, because they are the one that capture the data and provide to us the data. So we call them publishers. In MQTT, all your sensors will be known as publishers, because they capture data and they publish the data. So that connect to the broker. So the publisher, the sensor, normally will connect to something called the broker, and they will send their data there, okay, and go back to sleep whenever possible. So this is main job, the publisher, read the data from the sensor, send it to the broker, and that's it. This is the role of the publisher. Now you have the subscribers. Subscribers are those entities that have interest in the data. That, for example, you have a mobile application, you want to display the temperature. You want to have the temperature in a specific room. So the mobile application is a client that want to have access to the data, to the temperature of a specific room. So this is called the subscriber. So our application that are interested in a certain topic. Topic is any any data that you are monitoring. Can be temperature, humidity, distance, proximity, anything that you are monitoring. So this is a topic or sensory data. So they connect to the broker. So you see here, all the communication happen through the broker. When the sensor sends some information, it transmitted to the broker. When the subscriber want to have access to the data, it connect to the broker to have access to the data. So they connect to the broker to be informed whenever new data are received. Let's say you have shown interest in the temperature data. So as soon as there's a new data coming for temperature, you are a subscriber to temperature. So the broker will inform you, yes, you have a data for temperature because you have subscribed to this data. This is why it is called a subscriber. You subscribe to a specific topic for specific data. And obviously, the third component is a broker itself. It classifies sensory data. So its job is receive data from publisher, keep the data, and send it to the subscriber, and send them to subscribers interested in that topics. So it will not be sending it to all subscribers. It will be sending it to only those subscribers that have shown interest in that data that have been received by the broker. So if you receive a temperature, it will look for those subscribers that have subscribed to temperature and will send it only to those subscribers. You will see it in a diagram here. Have a look at this diagram. I'll give you a few seconds to have a look at this diagram. See what is happening in this diagram. Yeah, so you see the publisher on the left hand side capturing data and sending it to the broker. The broker classified it in terms of topics. So publisher at the top is publishing which data. If any student can answer, the publisher at the top is publishing which data? If you are asked this question. Anyone?
Sensor readings.
Which as per this diagram that yes, obviously all publishers, they are capturing some data through their sensors and publishing it to the broker. I'm asking the publisher, which is at the top, completely at the top there, it is publishing which data?
Topic 1.
Yes, exactly. You see the arrow goes to topic 1. So it is publishing topic 1. Whatever topic 1 I mean, it may be temperature, maybe humidity, whatever, but it is publishing. You should know that publisher at the top is publishing topic 1. Publisher at the bottom, completely at the bottom, is also publishing topic 1, whereas publisher at the middle, it is publishing topic 2. So this I wanted you to know. So each publisher, they publish some kind of data, some kind of sensor data that they are capturing, and they may not be capturing the same data. Depending on which sensor it is, it will be capturing different sort of data. So publishers, they capture different data and they send it to the broker. The broker classifies it in terms of topics. Okay. Now let's see the subscribers. Subscriber, which is completely at the top, has subscribed to which data, to which topic, to which data? Completely at the top, has published to, has subscribed to topic 1. You see, exactly. So subscribe to topic 1, whereas the one at the middle has subscribed to topic 2. The one below has subscribed to topic 1 again. So you may have subscribers, different subscribers subscribing to the same data, just like we had different publishers publishing the same data. We can have different subscribers subscribing to the same data, or to different data. So this is the publish subscribe architecture. If ever actually it was an exam question to explain how publish subscribe architecture works, so you can explain it using a diagram like this. And you explain, okay, you have publishers that is sending data, the broker classified in terms of topic, you have subscribers that subscribe to the specific a specific data, specific topics. You see down it is mentioned a message server broker matches publication to subscription. So what is this broker doing? It matches publication, data that we are getting from the publisher, to subscription, whatever interest that has been showed by subscriber. It matches those two, and as soon as we have a match, it will transmit the data. If no match, the message is discarded. Let's say I have received a data from a publisher, but no one has shown interest about this data. So what happened? If no match, the message is discarded. That is, we don't send it to anyone. If one or more matches, the message is delivered to each matching subscriber or consumer. Very often, this architecture is also, after you, it is known as, commonly known as publish subscribe, but you may see in certain literature, it is called producer consumer. Very obvious, why it is called producer. It produce data, and consumer, it consume data. It receive data. If there is a match, for example, for topic 1, we have seen 2 subscribers have shown interest in topic 1. The one at the top and the one at the bottom has shown interest. So the broker will send this data that is coming from the publishers. It's sending it to the subscriber at the top and subscriber at the bottom, if there is a match. So this is how the MQTT work, and this is how, in general, a publish subscribe architecture is. Let's continue. More or less the same thing it is explaining here. So we have a publisher capturing data. You see a light intensity, temperature, whatever. Okay, it send it to the broker. The broker send it to the subscriber. Okay, MQTT client. Yeah, now let me put the diagram again here. So these publishers, they send to the broker. Subscribers receive from the broker. So if we take the broker as a server, if the broker is a server, publisher is a client because it is sending it to the server for storage, and subscriber also is a client which is receiving data from the server. So we can say it is a client-server architecture. It is publish subscribe, definitely, but we use the term server for the broker, and for the others, the client can be 2 things. The client can be a publisher that is giving the data, or the client can be a subscriber that is receiving the data. So these 2 terms are important because you will see in the next slide. So MQTT client publishes messages to the broker. So when we say MQTT client publishes messages to the MQTT broker, to what client are we referring to here? Anyone?
Publishers.
Which one? I've not got the answer.
The publisher.
The publisher, exactly. Not the subscriber, because here it says MQTT client publishes messages to the broker. So it should be the publisher that we are talking here. It is a client. So what I want to tell you, that the publisher is also a client to the broker. So this is why it says MQTT client publishes messages to the MQTT broker. So message is published to an address referred to as topic. So particularly it needs to say which topic it is, which data it is. Now it says clients can subscribe to multiple topics. So we are referring to which client here?
The subscribers.
Yeah, this one we are referring to the subscribers. Okay, so just to tell you that a publisher is a client, a subscriber is also a client. Okay, clients can subscribe to multiple topics. Okay, that is different type of data, like after you limit light intensity, temperature, humidity, whatever, and receive messages published to the topics. Okay, so below you see some configuration details. Let me proceed. So the publish subscribe has 3 important characteristics. Yeah, why publish subscribe? What is so unique about publish subscribe? If you're asked what is I won't say advantage, but what is a characteristic of publish subscribe? So it has 3 important characteristics, this publish subscribe. First, very important characteristics, it decouples message senders and receivers, allowing for more flexible application. So this point is very important. One of the most important, if we can say, advantage or reason why do we use publish subscribe is that it decouples the message senders and receivers. That is, the sender and the receiver, they need not be there at the same time. They need not be communicating at the same time. So it allows for a asynchronous communication. That is, your communication need not be synchronous. That is, the publisher can, as soon as it captures some data, it send it to the broker. The subscriber, as soon as it connect to the broker, it receive the data. So they should not be there at the same time. So this is called decouples message senders and receivers. Very, very powerful mechanism. Yeah. Number two, it can take a single message and so you have how do we call this? When we take a single message and distribute it to many consumers. In networking, there's a term we use for number two. Anyone in the class?
Broadcasting.
Broadcasting, yeah, multicasting, broadcasting. So this is it take a single message and distribute it to many consumers, and you see it happening. You see it happening here, where topic one is being distributed to subscriber at the top, to subscriber at the bottom as well. So this is called a broadcasting this particular multicasting this particular topic to many subscribers. Not all, okay. Anyone can clarify when we say broadcast? Well, what is the difference between broadcast and multicast?
Broadcast is when the message is sent to all the subscribers, whereas multicast is when it's sent to specific subscribers.
Yeah, this is why one of your friends mentioned broadcast. The idea is okay, but then I've said more specifically it is multicast because you see it doesn't, topic one doesn't go to subscriber at the middle. It is not sending it to all actually. It is sending it to many, but not necessarily to all. To many, that is those subscribers that have shown interest in this topic. Yeah. So let's continue. We were here. Yes, number two. Okay, it can send a single message and distribute it to many consumers. So recall those points. These are technical points because you may be called upon to explain the characteristic of publish subscribe, why publish subscribe, how it is different from other architectures and everything. So here we are explaining it in detail. Third, this collection of consumers can change over time and vary based on the nature of the message. It's just saying that there is no fix. Like let me go back to our diagram. Like for the time being, subscriber at the top, I should have labeled it subscriber 1, 2, 3, probably easier for explanation. So subscriber at the top and subscriber at the bottom has subscribed to topic 1. This is not something static. What we are saying, third point here, is that subscriber at the top can say, okay, I no more want to receive data from topic 1. I am unsubscribing. Okay, I am removing my subscription for topic 1, and new subscriber can subscribe to topic 1 as well. So it is dynamic. This is the third point here. This collection of consumers can change over time. This is what I'm explaining to you. It is not something static. You can have new subscribers, or you can have old subscribers that don't want to receive the data as well, and vary based on the nature of the message. That is, new topics that are being published. So you see a very important characteristic of publish subscribe. You already see the reason, the advantage of using publish subscribe here through those characteristics. Let's proceed. Okay. Now the MQTT messages are delivered asynchronously. I've just mentioned to you that you need not be connected at the same time. The client, the publisher, and the subscriber need not be connected at the same time to the broker. They connect to the broker independently. This is called asynchronously, and very often it is called, I don't know whether you must have encountered this term, push notification. Push notification is that you just transfer to a particular place, and then it gets saved. Your message gets saved there through publish subscribe architecture. So the MQTT protocol works by exchanging a series of now you need to start appreciating that you don't have only your data that you're capturing, that we are sending. We can exchange a series of MQTT control packets. So if you have studied some networking, you know that, for example, acknowledgement and anything, these are control packets. And we do have control packet for our MQTT as well. You will see as we proceed a number of those control packets. So each control packet has a specific purpose. For example, in the table next to the here we have connect. Connect is a control packet. Client request to connect to server. Most probably subscriber is connecting to broker, or publisher is connecting to broker. Then you have ConAct server, so connection acknowledgement. Yeah, yes, yeah, we acknowledge the connection. Then publish. Publish is when you want to publish a particular data, publish message. Then a pub-ack. So here you acknowledge that it has been published. Then pub-rec, a publish receive. Okay, you just inform that you receive the message that has been sent. And pub-rel, a published release. Okay, that a client to server or server to client, we are releasing this this publication. Then pub.com is a publish complete. Okay, this is a delivery. This is part 3. So you see a delivery, actual delivery part 1, actual delivery part 2, part 3. These are steps we follow. And the same thing for subscribe. Subscribe, you subscribe to you sent a request. The request is acknowledged, and then you have unsubscribe. Recall earlier after you can unsubscribe to a topic that you have already subscribed. Okay, so this is unsubscribe. Unsubscribe acknowledgement, that yes, we acknowledge that this data has been unsubscribed. So all these are control packet. Here it is control. Each control packet has specific purpose. Every bit in the packet is carefully crafted to reduce data transmitted over the network. That is, we don't transmit unnecessary data, because if we do this very frequently, it will add to the network traffic. So Mqtt topology has Mqtt server and Mqtt client. I've told you already, the broker is a Mqtt server, and the publisher and the subscriber, they are Mqtt client. And Mqtt client and server communicate through different control packets. Those control packets that we have just below briefly describe each of these control packets. So you need to familiarize. As we proceed, you will see some example of those control packet being exchanged. Already you can see it here. Have a look at this one. This is communication happening between, at the middle you have your Mqtt broker. On the two sides you have your publisher and your subscriber. Note what happened. First, the publisher connect to the broker, and the broker sent an acknowledgement. Yes, it has been connected. Next, the subscriber connect to the broker, and there is an and this you see it is not happening at the same time. There is a timeline, and they can happen independently. Next, what is happening? We continue connect acknowledgement, and subscriber sent a subscribe control packet. Subscribe to what topic? To a particular topic, and you need to specify which topic you're subscribing. You note here home/alarm/1/status. That is, if we read this, in home, you have different alarms. I want to subscribe to alarms. Which alarm? Alarm 1. And what I want to know about alarm 1, I want to know its status. So this is how do we read this topic. And the broker say, okay, you have been subscribed to this topic. This is subscribe acknowledgement. And now you see when at another time, publisher published topic home/alarm/1/status. That is, a data has been received for what the subscriber had subscribed before. Okay, so it's the same thing, home/alarm/1/status. Why /1? Because there may be different alarms, alarm 2, alarm 3, alarm 4. So we are talking about alarm 1. And then once the data is received by the broker takes the decision, because there was a subscriber that had subscribed to exactly the same topic, so it will send this data that has been received, just been received by the by a publisher, whatever the publisher, it will send it to the subscriber that subscribed to it earlier, that have shown interest on this particular data earlier. And here we use the message publish. Okay, the publisher use the message publish to send to the broker. The broker use message publish to send to the subscriber as well. So this is how communication happen between publisher, broker, and subscriber. Okay, very important now. Now that you understand what is this publish subscribe architecture, how they exchange messages, what are control packets. Now there are a number of characteristics about the MQTT communication. First, we are going to study QoS. I think you know what is QoS, quality of service. In networking in general, for your communication, you have different levels of QoS. Depending on which level of QoS, what type of quality of service you require for a particular communication. Different protocols offer different quality of service. And our MQTT here offer 3 levels of quality of service. And you need to understand each of those 3 levels. Okay. Again, here you may have exam question asking you to differentiate between the 3 levels of QoS, or why given a scenario, which level of QoS you are going to use. Okay, you may be given such questions. So it is very important that you know very well each of those QoS level. I will explain. So let's start. There are 3 after you. There are 3 levels of QoS: QoS 0, QoS 1, QoS 2. So in QoS 0. What happened? The message is sent. It is about sending messages, obviously. The message is sent at most once. That is, it can be 0, we don't send at all, or it can be 1. And if it is 1, it is only 1. We cannot go beyond beyond 1. So, but it can be 0 as well. Okay. If I put my QoS at this level, at level 0, then I may send or I may not send. If I send a particular data, it's only once. Otherwise, I will never send again the same data. When I receive new data, I may decide to send or not to send, or to send it only once. So this is at most 1. Does not provide guarantee of message delivery, obviously, because you're sending only once. Even if the message has not been received on the other side, you will not have any mechanism to confirm that it has not been received, and you will never resend the data. So you understand what is the problem here. Okay, so it is not guaranteeing that the data is being received by the receiver. You see in bracket it says with no confirmation. It is at most once. I've received the data, I've already sent it. Whether you receive it, you don't receive it, I don't care at this level of QoS. Let's move on to QoS 1. QoS 1 at least once. You see here, as opposed to at most once, we're talking about at least once. It is possible to deliver a message more than one. When you say at least once, once the data is captured by the publisher, at least once I need to transmit it. There's no probability, there is no possibility of 0. At least once we need to transmit, but not only once, it can be more. It can be more than once. Okay, it says with confirmation required. If I don't receive any confirmation for a particular data that I have sent, I can retransmit. I retransmit the data. So this is why it says at least once. It can be more. It can be more than 1. This is QoS level 1. Now QoS level 2, the third one, QoS level 2, it says exactly once. Now you may be confused between at most once, QoS level 0 and 2. No, it is different. Exactly once. Message is sent exactly once by using a 4-step handshake. So there's a difference between at most once and exactly once. At most once, it can be 0. Exactly once, it is once only. Okay, so there is a difference there. However, this one, it uses, I don't know whether you have studied handshaking. If you have studied some networking, here we're talking about a 4-step handshaking, where you connect, then you acknowledge, then you transmit, then you acknowledge whether you have received or you have not received. So this is handshaking. You perform handshaking for your transmission itself, to establish your connection, and for the transmission itself. So this is different. So selection of which one you are going to use for your MQTT, it depends on your system requirement. It depends on what type of application that you are developing, what type of IoT system you are developing. I will show to you. I think I have added. Yeah, I have added those diagrams. It was not there before. You see here each one what it means. So QoS 0 just transmit. Okay, it transmit to a broker, an MQTT client. It's transmit. You have an Hive MQ broker here. I will comment on the type of brokers that we have. So just transmitting. Whereas QoS1, you transmit and then it is acknowledged. Yes, we confirm that it has been received. If it has not been received, you can retransmit. Whereas this is a handshaking I was just talking. So you publish at QoS 082. We want to transmit at this level using this QoS. Pubrec, it is you recall this pubrec in our control. It is pubrec, publish, receive. We receive. This is a step part POP1. Pubrel, publish, release, and pubcom, say publish, complete. So let's come back here. So rec, receive, here release, okay, and here complete. You see all these 4 steps actually have been performed. This is what is called the 4-step handshake that is happening using those control packet that we have already seen before. Okay, so these are the free QoS levels that we have in MQTT. And when you're transmitting, when you're implementing an MQTT communication, you normally have to specify which QoS level are you using, 0, 1, or 2.